Hello, welcome back to Learning with Ms. H. Today we're going to go through Earth Science's lesson on star classification. So your bell work is to tell me what's the major difference between a red giant and a supergiant star. That was from the last lesson. So jot that down in your notebooks. Be prepared to be able to answer that question on future assignments or tests. What we're going to look at today is classification of stars using an HR diagram. And then the homework assignment down here. Now the homework assignment is to interpret an HR diagram. There's a link here that is an answer document that has all of these questions typed out on it, so you can type your answers directly into that document. And all you're going to do for this assignment is take a look at this HR diagram here and answer all 14 of these questions based on this diagram. You're not going to be able to do that until you've gone through the notes, but that is all you're going to do for today. So click this link, make your own copy of the answer document, and then have this page open, type your answers into the answer document, turn it in through the Google Drive tab. So for the notes for today, let's take a look at classifying stars. So how do we classify stars? You need something to write with, something to write on. Let's go ahead and pause me while you get that together and then come back for the notes. All right, welcome back. To classify stars, we're going to look at the different properties. We're going to look at the mass, the luminosity, the temperature, and the spectral type. So the mass is the property that determines all of the other properties of the star. So the amount of mass or the amount of stuff in the star is super important to us. So mass, remember, is the amount of matter that makes up something. Different from weight. Weight is the pull of gravity on that mass. So with properties of stars, we are just looking at mass, the amount of matter that makes it up. Luminosity is the total amount of energy or light that the star emits into space. Temperature is how hot the star burns. Sorry about that, that's the bell. Spectral type is really closely related to temperature. We're not going to worry as much about that one as we are the actual temperature and luminosity. Spectral type is going to be kind of the color that's put off by the star. So what can we measure directly? Well, the easy things to measure are apparent brightness, temperature, and spectral type. So we can look at the temperature, the color, and how bright it is. Some harder things to determine and measure are the distance the star is from us, the size of the star, and the mass of the star. So when we're looking at apparent brightness, that's going to be how bright the star appears to our eyes. From our perspective, how bright is the star? It's going to depend on luminosity and the distance between the star and Earth. So apparent brightness is how bright it appears. There's an equation here for it. And then we've got a little image over here. The closer we are to the star, the brighter it's going to appear because the less diffuse the light is. You can see in this cone, if we were at this spot where there's only one square here, the star would look a lot brighter because all of the light's concentrated in this one square. Moving out, it's now concentrated in these 4 squares. So the light's being spread out. The further away you go, the more the light gets spread out. So apparent brightness is how bright it appears to be from our perspective. And usually our perspective is here on Earth. Magnitude, this is how bright the object actually is here. So the apparent magnitude is how bright it appears to be. The absolute magnitude is how bright it is from a specific distance. The specific distance we use is 10 parsecs. So if we were to go 10 parsecs away from that star, how bright would it be? That's the absolute magnitude. And we use that so that we have a way to compare different stars to each other. when we're looking at apparent magnitude and absolute magnitude, the larger the magnitude, the fainter the object. So if you have a magnitude of positive 30, that's going to be a lot more dim than a magnitude of negative 30. So again, apparent magnitude, relative brightness of an object. The first magnitude star is 100 times brighter than a sixth magnitude star. And a difference of 1 magnitude is a difference of 2.51 in brightness. And again, larger magnitude, fainter object, and negative magnitude is always going to be brighter than a positive magnitude. Spectral classification. We're looking at spectral classification. This is going to be the color of the star. We represent this with a letter, and the color is going to be indicative of the temperature. So color and temperature are very closely related. O represents blue, which is going to be the hottest star. M represents red, which is going to be the coolest star. 0 to 9 is the brightness of the star. 0 is the brightest, 9 is the dimmest. And then we have a Roman numeral to tell us where it falls on the HR diagram. So our sun is a G2V. So G for the color, 2 to represent the brightness. Remember that 0 is the brightest, so 2 is pretty darn bright. And then V for where it falls on the HR diagram. And we'll take a look at that in a second. As far as colors, you need to know that O represents blue, M is red. I would take a look at the G and know that that is white to yellow. Know that we're going to go red, orange, whitish yellow, blue in that order, with the blue being the hottest, the red being the coolest. Here's our surface temperatures, approximate average masses and radius, and then average luminosity here, characteristics for each category. We're going to focus on these first 3 columns here and this luminosity column. We're going to work with this some more when we get into HR diagrams. I would still go ahead and make sure you get this table into your notes. Go ahead and pause the video until you're ready to move on. Okay, so luminosity. Luminosity is the total amount of light that a star puts out into space. If we know the distance to the star and the apparent brightness, we can actually infer the luminosity from that information. So luminosity, the total amount of light a star puts out into space. Luminosity of some stars. These are some very common stars that we look at. Some of these will be in your homework today. So we've got the star, the distance from us, spectral type, and then luminosity. So you do not have to have this table down in your notes. You don't have to know these specifics by heart. You do need to be able to recognize what the different terms mean and be able to read this and understand what's going on here. This is an HR diagram. We're going to do a whole slide presentation in our next slideshow here coming up shortly. I'm talking about HR diagrams, but it's basically going to show the relationship between temperature and luminosity, as well as the mass and size of the stars. So don't freak out about this yet. We're going to go through this and look it over and really dig deep and analyze this chart so that you know what to do with it. And then your homework is going to be to actually read one of these charts. Once you're done with this, go ahead and move on to the next slide presentation if you are watching alongside me in Canvas. Okay, so we are going to move on to HR diagrams. These are super short. They're actually even shorter than the last. You need to be able to read an HR diagram. So HR diagrams are how we classify stars. It's named after Hertzsprung Russell. That's why it's called the HR diagram. And what we're looking at here is luminosity versus temperature. We're comparing those two properties of stars, and we're looking at how they correlate to each other. So when we're looking at properties of stars on the HR diagram, luminosity is going to be a logarithmic scale, 10 to the something power. Temperature and spectral type are going to be down here along the bottom, down here. Size of the star is going to be represented in here by the actual size of the star on the chart. Mass is represented up here as well. And then the lifetime of the star, you can actually watch the lifetime of the star come through here, and we'll explain how that works. So, HR diagrams. When you are looking at this, the temperature on this scale decreases as you go from left to right. So this arrow shows an increase in temperature. So it is hotter on the left than it is on the right. That means that all of these stars on the left are going to be blue, and they're going to fade out to red. For luminosity, remember that it's a logarithmic scale, and it's going to increase as you go up. So these arrows on here show you an increase in whatever we're looking at. So an increase in temperature right to left, an increase in luminosity bottom to top. For mass, when you're looking at all of these stars up here and you're taking into account mass and size, you're going to have mass increasing from the lower right to the upper left. So you get more and more mass this way. You're also going to get more and more size, but it's going to go from the lower left to the upper right. So these guys down here are smaller than these guys up here. You can watch the lifespan of star. You've got the hottest stars up here that are blue. As they start to burn out, they start to die off. They'll become supergiants or giants. So you've got all of these stars that are different sizes in the main sequence. This line here, right down the middle, is the main sequence. Those are called main sequence stars. These are stars that are in the main part of their life. They're burning that helium, hydrogen into helium. So they're creating that helium in this range. Okay, so this is hydrogen converting to helium through nuclear fusion. And as the stars start dying off, they're going to move from main sequence up here into supergiants or giants. And then as they totally die off completely, these giants are going to come down here and become white dwarfs. So temperature increases as you move to the left. Luminosity increases as you move up. Mass from the lower right to the upper left. Size from lower left to upper right. You need to be able to read this chart to know what's going on. So this middle row is main sequence. These are your healthy stars, hydrogen fusion turning into helium, high mass, very high luminosity. They have high temperatures usually. There's more of them up here at the top than at the bottom. Supergiants and giants. Those are up here in the top right. They are dying stars. They're fusing helium into heavier elements. There's no more hydrogen left. And then you have white dwarfs down here in the bottom. They have an exposed core. There's no more nuclear fusion at all, and they are dead stars. So when you go through an HR diagram, you're going to be looking at where the stars are falling. Find the name of the star you're looking for, look where it's at, and you can tell any of those things about it just by looking at this graph. During the lifetime of a star, it's going to move through this graph, so it may be in a main sequence now, and as it starts to get older, it's going to move into either supergiant, giant, and eventually die off. So your homework is to look at the HR diagram that is in the homework assignment here, and you need to be able to read this HR diagram and answer these questions. It is not in color, but it does have the colors listed along the top. So this column is blue or blue-white. This column is white, yellow, red, reddish-orange, red. so you can see what's going on there. That is all for today. Have a good day, and I will see you next time.